Hey guys, this is Jan from DoraHacks, and welcome to the workshop of the Xion Believer-thon. Today we are having the first episode of a mini-series consisting out of 3 workshops about Dapp development. It's a speedrun, and each session will guide you as a hacker through the complete process. It's a speedrun, and each through the complete process. Sorry. So as a hacker, you will get a lot of information about how to write, deploy, and query smart contracts. And before we start, let me also give you some background of this hackathon. For DoraHacks, as the largest Web3 multi-chain developer platform, it's an honor to support the Xion Believer-thon. And we're looking forward to all the incredible projects building at this hackathon. And today we're very happy to have Angela Devrel from Xion here. And without further ado, let's welcome Angela to start. And for the audience, if you have any questions, feel free to just drop them in the YouTube or Binance live chat room.
Hello. I can go ahead, right?
Yes.
Okay, thank you. Hi and welcome everyone. I will be going over like a quick speed run of setting up your Cosmosm smart contracts and creating like a quick front end. Depending on how much time we have, I'll be able to take in a few questions here and there in between the sections when I'm switching context between sections or towards the end. So feel free to drop in the questions in the chat and I'll be able to go over them now and then whenever there's like some time between the sections. So I will just share my screen and go over the stuff that I'll be talking about. Okay.
Okay, we can see your screen and feel free to start.
Thank you. Okay, so this is like a rough overview of what I'll be going over in this speed run. It is so I'll be going over an introduction to blockchain development. Also, for this speed run, like this particular part and this particular series does not expect any blockchain experience before this. Having blockchain experience or having coding experience is obviously beneficial. So like having any experience with Rust or Solidity or coding in general is going to help a lot. But if you're new to blockchain overall, but have some coding experience, it should be totally fine to follow along. Another thing to keep in mind is that I don't expect you to follow along in this video because this workshop is going to be recorded. So feel free to look up the recording and then follow along if you're not able to keep up, or if you're confused about any steps that I'm skipping or any steps that I just skim over, because I would have a lot of things already installed in my system, so I won't be waiting for it to be installed. So I will be skipping the installation parts, but feel free to keep that for later or make a note of it for now. And just for this series, you can just see what's happening and try to absorb as much as possible and ask as many questions as you can. So yeah, like I said, I'll be going over an introduction to blockchain development, just skimming through it, like a quick rundown of what blockchain development means, what a tech stack includes it when you're starting to create a new dApp, what exactly entails in picking a chain to develop on, and how Zion is different from the chains out there, and why exactly you should build on Zion. And this, so third and fourth go hand in hand in terms of understanding the mental models that dictate a chain's development or dictate developing on a particular chain. And then towards the end, we'll be going over like a quick Hello World Cosmosm smart contract. I've written Hello World. We are not really writing the Cosmosm smart contract from scratch. That'll be for a different workshop in this series. It'll be tomorrow. But for now, we'll just be using the CW721. Like we'll be using a template smart contract and we'll be deploying that. And we'll be querying it via the CLI, and we'll try to put together a quick front end if the time allows us. If not, we'll just continue it over to tomorrow. So now I'll just get into it. So yeah, like this is a blockchain. I didn't know. I couldn't think of a better representation here. But yeah, like in a sense, blockchain is like blocks of transactions. So a very high level overview of what exactly a blockchain is, in my sense, I would just call it a data structure. Um, and if you're familiar with data structures in computer science, or if you've done a computer science degree, you would know that there are different kinds of data structures like linked list, queues, stacks. So I would call blockchain a data structure, but the only difference being that it is a distributed data structure, um, in the sense that multiple different nodes or computer systems run the same data structure and they all agree on a certain way of coming to consensus, which is called the consensus algorithm in blockchain. So think of it this way, that there are multiple nodes and they all want to agree on a certain thing, but the way they come to an agreement is based off of a formula or based off of a certain protocol. And that is what we call a consensus algorithm. Each block in a blockchain is basically just a set of transactions that all of these nodes are executing on their own individually, and each transaction is a set of atomic messages. So, for example, one transaction could include both these messages, which is Alice sending Bob 10 new Zion, and Alice also executing a function on a smart contract. And both of this makes up one transaction. The way transactions work is that if this goes through, but if this doesn't, uh, let me just use this. But if this doesn't, then the whole transaction fails. So this is why I call these atomic, and this is what you need to keep in mind. So for example, if you're writing a smart contract function in which the first execution line goes through but the second doesn't, the whole function call would fail. So yeah, and in a sense, like when you collect a bunch of these confirmed transactions, so let's say if this was confirmed, uh, a bunch of these confirmed transactions into a data structure, which is eventually called a block, you basically are creating like a blockchain in such a way. So I don't want to go into too much details into how the Merkle roots are formed or how these are hashed together to form this linked list, because this is a whole sort of workshop in its own and it is extremely theoretical. But for now, for our purposes today, this is enough to know how transactions are formed and what exactly blockchain is. We'll be heading into the tech stack of a dApp now. So, in terms of, you could also call it anatomy of a dApp. Basically, any dApp that you're trying to build would have these components. So you'll have a client, ideally with a front end, and you'll have a chain that you would have selected. So in our case, it's the Zion chain that we are building on. It could very easily also be any other chain, for example, Ethereum, Solana, whatever. So so chain is a component in your dApp, which you pick, and then the client is the front end. The SDK is usually provided by the chain. So, for example, Ethereum has Ethers.js, Zion has Zion.js, and Solana has Solana.js. I'm not sure exactly what SDK they use, but usually you'll be able to find an SDK that the chain provides that are helper tools or helper functions that will that you can call into your front end to interact with the chain. So, for example, Zion.js, and for client, this would be the front end. And the other component is the backend, which is basically your server or any other API calls that you're making on or the database, the indexer, anything that sits between your front end and your chain, um, or is doing some data storage or is doing some external function calls that are not entirely on the client, will be a backend. Most applications in Web3 are client only. which makes, because most of the backend and business logic and storage happens on the chain. This is why you'll see less of this in most of the client applications. And even when you're starting out, you don't need a super high efficiency or optimized backend at all. You can just have a client and a chain, and you can create a whole dApp on it. But production ready dApps usually have a backend, because you would eventually want to store some keys somewhere, or you would want to query the indexer, or you would want to create your own indexer, depending on how complex the dApp is that you're building. Usually there's a database too. So for example, when you're logging a user in Zion's case, let's say you're logging a user in, login usually happens between client and chain directly in Zion. So once that happens, you eventually want to store users' profile somewhere. So, maybe you'd want to collect their names, their emails, their profile picture. So all of that would go into the backend in the database. So this is what your dApp would look like. And there are a bunch of frameworks that'll help you set this up quickly. And we're going to look into a few today. Next, before getting into the coding part, I just want to talk about this aspect of your dApp, the chain, and why and how you can pick a chain, and why do so many chains exist, etc. So, I would talk of chains as state machines. So I've written chains and state machines here, but actually chains are just state machines. So there's a state that this data structure that I talked about exists in. So this data structure exists in a certain state. So for example, let's say there are just 4 blocks in our blockchain, and they have like 10 transactions each. And this exists. There's no new blocks being formed, and that is just the world state. And 10 nodes or 10 computer systems have agreed that, this is the state and this is it. So we can call that state as S1. And now for the blockchain to, create more blocks and proceed forward, have processing happen in between these nodes, we want to go from S1 to S2, which would be some other new state that is based off of S1 and adds something new. So in our case, in blockchain's case, we'll be adding one new block, let's say. So the way we go from S1 to S2 is usually based off of a function, and that function is based off of S1. So think of it this way, that going from state 1 to state 2 involves doing something with state 1 that produces state 2. So here I'm calling state machines a framework which governs the system state. That's it. So when I say a chain, or when I say state machine, all a chain does, or all any blockchain does, is it provides you a framework of changing from one state to another. So if you think, you could literally compare all of the blockchains out there based off of this just one mental model, which is of state machines. I would also just call it a mental model here. So you could compare all of the blockchains out there based off of this mental model. So for example, Ethereum has, Ethereum's consensus algorithm is the state machine transition function, which is proof of stake. Bitcoin's state machine transition function is proof of work. And for Zion, it's proof of stake. And with this also, you can also think of it as defining how we change from S1 to S2. And the other thing, that FS1, which is basically the consensus algorithm, it ensures that all of the nodes inside of that network agree on a certain state. So here I'm just writing in short that state transition function is basically just a transaction. So this function is a transaction, and state transition framework is the consensus algorithm. So like I said, you go from initial state to a confirmed state, and the rules to interpret the transactions are what define the consensus and what defines the chain eventually. And this is, I don't again, this is also something theoretical, and we don't have to go too deep into it. It's again just a helpful thing to keep in mind when you're getting into blockchain development. And that's it for the first part. Actually, I can take a few questions if there are any, and if there aren't, I can just get into the coding part.
For now, there's no questions, but maybe there's like some questions coming up during the coding part.
Okay, no problem. I am gonna share my screen again. And can you see my screen? Okay.
Yes, it's visible.
Yeah. Okay, so that's great. If there aren't any questions, I'm just gonna close this and open this and go over. I'm just gonna put this here. And I'm just gonna open CW's NFTs for us. So for this application that we are building today, I'm gonna be using Cosmosm's template of NFTs. Not templates, so they already have predefined contracts that are out there for any developer to use. And in a Cosmosm ecosystem or any CW based chain, it is usually recommended that you pick an already existing contract on the chain, or already existing standardized contract on any open source repository to build off of your project. Because, well, I can go over this like super quickly. I can squeeze this in here. That what happens in so when we're building in Solidity or any other blockchain, usually you have a smart contract that you deploy on the chain, and you get a unique address associated with it. um, if so, this is one DApp. If there's another DApp that needs to use the exact same contracts, even if this is a standard 721, let me just call it ERC 721. This is a standard 721, and the code would remain the exact same if I were to create a new DApp that uses ERC 721. But I cannot reuse the code that's already been deployed. So when a user deploys a smart contract on Ethereum, for example, they pay for the storage space, and they pay for the transaction of the deployment, and they get their storage space for the standard contract ERC 721. If I want to create that again, and if I have my DApp that uses 721 again, I'm basically paying the same cost again just to get a different hash here. Which just means that every single time you're getting a new contract on the chain, you're paying for the storage space all over again, and you're paying to store the code all over again, even though the code doesn't really change. It's just the storage space that changes. And this is any non-Cosmosm based chain, or any chain that does not allow sharing code. A difference here between Ethereum and, let's say, Zion, is that because Zion is Cosmosm based, you can do something like this, where if if a CW 721 in this case already exists on the chain, I don't need to deploy it again. I need, so usually a code or a smart contract is stored with a code ID. So let's say a code ID is defined here. Anyone who needs to use this code just basically deploys their own instance and gets their own unique address. So they're only paying for instantiation. They're not paying for the deployment of the code all over again. So I get my unique address, and someone else gets their unique address, and on it goes. So this is why most of the Cosmosm tutorials, such as this one, would encourage you to look into public repositories like these, which are, and it's even better if these are maintained by the developers of Cosmosm, or maintained by some bigger organization, so that you know that these contracts are vetted for, and you can just easily deploy them on the chain. Even better than that would be to sort of look for code IDs on the chain. There are some advanced explorers that would allow you to query the explorer to look for the particular code ID. So, for example, I could look for 721 on the Zion chain and figure out what the code ID is, and then just use that code ID to instantiate my contract. We're not going to do that in this tutorial, but that is something to keep in mind. Because we are going to be learning how to deploy the contract, I'm just going to be looking into a standard contract in the public awesome repository that has CW NFTs, which is something relevant for us. And in here, I'm just going to expand.
Sorry for interrupting. Right now, we can just see like the GitHub page. If you're trying to like have two windows, maybe you need to change something in your settings.
Oh, yeah. Thank you for letting me know. Oh, right. Okay.
Maybe present entire screen.
Here, can you see both these windows now?
That's perfect. Thank you.
Okay, thanks for letting me know. Yeah, so this is the repository. Well, I actually didn't do anything on this side of the screen, so we're good. But yeah, so this repository is gonna help you in, picking the standard NFT contract that is relevant for your dApp. So for example, in our case today, we're just gonna be using the CW721 base, but you'll be able to see that all of these other example standard contract, these are not example contracts, I'm sorry, these are all standard contracts that you can pick and use right away in your application. So I am just gonna do that, and let me, okay, I'm just gonna make a demo directory, cd into it, and the way to go about it is that you sort of clone the repository. I'm gonna clone it, and I'm just gonna look into the code for a sec. So if you look into the code, you'll see that this is what these are the directories and files that CWNFTs comes with. You can look into the contract, and CW721 base is what's important for us, and this is what we're going to look at. There are certain examples as well. So for now, we are not going too deep in here, whatever happens here. We're just going to take this as a given, and we are gonna go back into our terminal. And so now we're gonna try and compile this. So the way to compile any contract on in Cosm Wasm system is to use an optimizer. It is recommended to always use an optimizer. And Cosm Wasm provides a Rust optimizer, which basically takes your contract and it compresses it in size. So the Wasm bytecode that is generated is much smaller in size and much easier to upload on the chain. Now, what do I mean by Wasm bytecode? So whenever you compile a contract, so you'll see here is what you have. So you have state, message, library, error. So all of these are Rust files. We basically want to compile these Rust files into something that the chain can understand. So we are gonna be compiling all of this, convert it into a Wasm bytecode, which is the language that the chain will understand. It is like the binary that will be run on the chain every single time you're trying to query the contract or you're trying to do anything with it. So we want to convert it into that, and then we want to upload it on the chain, upload or deploy it on the chain. So the way to go about it is that Cosm Wasm provides this optimizing compiler, and it provides you this Docker command that you can run in your code base. This is going to take care of everything for you. So you don't have to go into each contract or try and compile it or write any scripts for it. All you have to do is basically run this command into your system. And if I'm not sure if people have already followed the first workshop that was done last week, but we basically installed all of the required software in the last workshop. So you must have Docker already installed, Go, not, well, yeah, you should have Go, Rust, Cargo, and so I'm just going to zoom it in. Yeah, so you must have Docker, Go, Rust, Cargo, and you must also have Zion D installed for this, for what we are doing today. Even if you don't have all of these installed, I would recommend going back into that workshop, or I'll share a Notion page with all of the all of the required, like the list of all of the software that is required to be installed, and you can do that after the workshop ends. So like I mentioned before, don't feel pressured into following exactly what I'm doing today. You can look into the recording and then follow along. But for now, just remember that we would need at least Docker Go, Rust, Cargo, and Zion D installed in our system. So yeah, now that, because I already have Docker installed, I'm just gonna do this. I'm just gonna pick this whole command. I'm just gonna clear this. So I'm in CWNFT's repository, and I'm gonna paste this here, and it should do all of these stuff for me. So that now I just have to wait for it to finish doing its thing. I'm just gonna do this, and until it, so it's gonna take a while until it compiles, optimizes, and creates an artifacts directory. So artifacts directory is already here. So we're gonna see here that it's gonna fill it up with binaries for us, which is something that we'll use to upload or deploy to our chain. Until that is finished, I'm just gonna take my time to maybe create a directory here for my front end. And for that, I'm just going to be using create next app. I think it's npx create next app latest. So I can either do this. So you can either just start with a basic blank next app framework, which should work fine. The only thing is that you'll have to set it up with a lot of different prerequisites that are required for you to start building on any chain, and including Zion. But instead, what you can also do is head into our documentation. I'm sorry, that's not the link. And you'll be able to see a reference guide regarding the building your first app. So you want to get into building React app with account abstraction. And here you'll be able to see all of the other, there's a whole Next.js Zion abstraction example that you can use to bootstrap your application as quickly as possible. So I'm just going to pick this whole thing, and I'm going to paste it here. And so as you can see, it will install Tailwind for me. It'll have ESLint. It'll have all of the important stuff that I would need to set my application as quickly as possible. So I'm just going to do this. Would you like to use TurboPack? No. And yeah, now we're going to wait for this to install, and I can look in here. It is still optimizing, which is fine. It is expected to take a bit of a time, also because we have a bunch of contracts here. So even though we are just going to be using CW721 base, it is sort of looking into the contracts directory and compiling all of these and optimizing all of these, which is good for us. So if you end up following this workshop, you can pick up any other contract from here, and sort of depending on the idea that you're working on, you'll be able to deploy it. And we have our Next.js set up here. Now we're going to look into the SRC. What we've got is this. Let me just... So I can see that it gave me a layout already installed, like nicely set up with fonts, with my root layout set up, with my page here. I'm just going to try and run it in a bit, but let's see the dependencies. So for dependencies, I have all the dependencies that I would need. That's great. So now I'm just going to cd into my Next.js app, and I'm going to pm run dev. So this is what our application looks like right now. It's just a basic Next.js boilerplate. Nothing crazy going on here. What we want to do now is make it ready for Zion, or make it ready for our contracts to be able to query from the front end. I would want to get into this, but for now, because our contracts are compiled, I want to get into the contracts first, and then we're going to get into the front end if time permits. If not, we can also get into it in tomorrow's session, which will be part 2 of what we are doing today. So for today, what we have up until now, what we have done is sort of gone over blockchain development, gone over the anatomy of a DApp, and gone over what exactly differentiates one chain from the other. Basically skimmed over state machines and state transition functions. And now what we just did was basically we cloned the CW NFTs, the public awesome CW NFTs, and then we compiled, and now we're going to be deploying the NFT on Zion chain. And through the deployment process, we'll sort of go over a bunch of different like fundamental skills that you would need to deploy any contract in the future as well. So I'm just going to zoom it in because we're going to stay in the CLI for a bit. And once we have our contract address, that is when we'll be good to go into our front end. So the idea for now is to get to our contract address. And to go over that, like I said before, so you have your code. From your code, you get a code ID. And from the code ID is how you get into your contract address. This is slightly different from the way it works in non-COSM-WASM chains, because in non-COSM-WASM chains, you just go from code to deployment to contract address. In this, we'll get a code ID first, and then we'll get into the contract address. So the next step for us would be using Zion D. I'm just going to zoom it in a bit more. So the next step, I'm just going to clear everything. So next step would be to be using Zion D to deploy our contract. We already have the artifact installed. So we can see the artifact is in artifacts. So this is the WASM binary that we are interested in. All of the others are from the other contracts that we don't really need today. But yeah, so this is what we want to sort of deploy / upload. And let's see what we can do. So we have Zion D available for us. And in the last workshop as well, I mentioned how you can always use Zion D's. I'm sorry, that was a bit loud. Yeah, so in the last workshop as well, I mentioned that you can always use Zion D to sort of use the help command here to see what commands and subcommands are available to you if you get stuck anywhere, because this has been super helpful for me in my development process. In my case, I am just going to be using TX, and let's see what's available for us. So because I know that I'm going to be sending a transaction to deploy my contract, I just knew that the main command is TX for me. And then after that, I am going to look into here, WASM transaction subcommands, because we want to do something with WASM. So I'm going to do this, and let's see what's available here. So in WASM subcommand, we have a bunch. So execute a command on a WASM contract is something that we can do later, which is good to know that we have execute. We have instantiate to instantiate the contract, which is something we'll do next. But before that, first we need to upload the WASM binary. So like I mentioned, the WASM binary that I just showed you, CW721_base, this is what we want to upload to the chain. So we're going to be using the store subcommand. So I'm going to be using store, and the parameters that store takes is the path to my binary and the other flags after this. So we're going to just confirm this once and store WASM file, the path to the WASM file, and then the flags. That's correct. So we're going to give it artifacts. Actually, we are inside artifacts right now. So we're just going to give it CW721 base and the flags. So now the flags is kind of the important part here. So you want to make sure that the command is able to reach the RPC, which is the Zion testnet RPC. It knows the chain ID that it wants to upload on, the gas prices. gas adjustment, and we also want to give it the from address, which would be the from account that you're signing from. So just make sure that you have enough funds in the account. So these, if you do a Zion D keys list, it'll give you all of the accounts that the Zion D CLI has access to on your system. In my case, I'm just going to be using my test account because I know I have enough funds in here. I'm not exactly sure though, but we'll see. We'll see if I have enough funds in here. But yeah, this should be your query command, and apart from that, now we are good to create a command for the storage. So Zion D wasm store CW 721 base, and next I am gonna add gas adjustment. Actually, a quicker way would be, so because it's really hard to remember all of the flags in here, you can always look into our documentation for this. In the documentation, if you go into your first contract, deploy a Cosm Wasm smart contract, you'll see all of the flags mentioned here. So you can simply pick stuff from here and sort of copy it around. I'm just going to do the exact same thing. I am going to try and see if I can paste. Okay. So this is what we have now. So we have gas adjustment. For the gas adjustment is the factor that the gas price gets multiplied to. Gas here is auto, which is the gas amount is being simulated and generated automatically. This is just a flag so that the output is returned in JSON. Chain ID is something that uniquely identifies the chain that we are trying to deploy on. RPC, like I mentioned, is the chain that it will interact with, and the from test account, which I just shared. So let me see if this works. Whoops. Oh, I forgot one subcommand. It should be tx wasm store. Okay, that's great. So it worked. We're actually not entirely sure if it worked. Let me just copy this. This is something that you can do as well. Either go to the Explorer, explorer.burn.com. So whenever you have a transaction hash, you can easily query Zion testnet, press, and see if it went through. It did go through, which is great. Other than that, you can also always do Zion DTX query and paste the transaction hash over here, and obviously give it node, which would be this 443. And I think it requires chain ID as well, but we'll see. Oh yeah, it requires chain ID. Chain ID. I'm just gonna give copies here. Oh, it's still not happy. Zion DTX query. Oh, it does not require node. I'm sorry. Let me just Zion DTX query. I always thought one sec. Node HTTPS. Let me just try removing the flags and let's see if the query works. Oh, sorry. I realized what my mistake was. So you want to do Zion D query and then TX. Oh, and then give it the node. So, oh, oopsies. I'm sorry. And then you want to give it the node, which will be this. Okay. So that's great. So all of this log really doesn't mean anything for us right now. What we are really interested in is, well, one, if the transaction hash transaction went through, which it did, which is great. Second is the code ID that it should have returned. So one way to look for code ID is basically in, oops, sorry. I'm just gonna try to squeeze it in here. It is not happy. I'm just gonna, yeah. let's just put it here. So yeah, next thing we're gonna, so the transaction went through. This transaction uploaded our wasm binary onto the chain, which means that it should have returned a code ID. So I'm just gonna look for code ID here. Maybe it doesn't tell me anything because it's deep inside the logs. So I'm just gonna scroll all the way down, and if you, whoa, so if you, actually, this is something that you won't have to do always. I have a handy command for you to just query the code ID directly, but it's always good to know that where exactly you can look for code ID if you were looking for it in the Explorer. So you want to look into somewhere here. Here. That's your code ID. So usually it's in the attributes array, which is the last object of the events array, which is here. So events array. So I'm just going to close all of these so you can clearly see what I mean here. So transaction response will always be an object. It will always have an events array. And the events array would, the last object of the events array would have a few attributes, and the second attribute would be the code ID. So this is something that you don't have to remember always because there's a command for it. I'm just going to share that command with you. So if you, let me just, so Zion D query TX, and the transaction for us was this here. I wanna do the node thing RPC, and I wanna do output in JSON JQ R. Again, this is something that you don't have to remember. Even I don't remember this. I usually have it handy written somewhere, or you can always copy it from the documentation. So if you go into the documentation, you'll be again in the same file, which is the guides, your first contract, deploy a contract. Here you'll be able to see here. So you'll be able to see a lot of little tricks around here wherein you pipe the output using you pipe the JSON output into JQ and sort of query exactly what you're looking for. And this is what I'm doing right now. So I'm piping the JSON output into JQ, which is a helper CLI tool. And I'm just looking for logs, like I mentioned, the last object in the events array, and just looking for attributes in it. So I'm just gonna do this. I'm gonna copy over what I just showed you. And yeah, so I'm looking for events, last object, I'm looking for attributes, first object, and the value. And 1459 is the code ID, which is good. So this is something that we can note down. Again, 1459, now that CW base NFT is uploaded on Zion testnet, anytime you use 1459, you'll be able to instantiate your own NFT contract. So next now that we have this, I'm just going to store this into a variable in my CLI. Let me just call it 1459. And if you echo, okay, great. Now what we're going to do is we have the smart contracts. So if you remember from the Excali draw that I was drawing in, so we are here now. We have the code ID. Next, we'll do this part. We're basically just following this arrow to instantiate our own contract now. So the next thing for this would be sort of figure out how the contract needs to be instantiated. For this, we need to look into the code for a sec. We'll look into the contract, CW721 base, and we will look into the message. This is important for us. I won't need this. Okay, so you basically want to look into the instantiate message. What I usually do is just find in the folder and look for instantiate, wherever instantiate is mentioned. So usually schema would be the best place to look into exactly what the instantiate message requires. And if that's not it, here. So the schema usually generates a JSON, and this is what's important for us. So that is what we are exactly looking for. So when you search for instantiate in the directory, look for either schema or CW or contract name.json and get into the instantiate object, and that's it. Here you'll be able to see properties, and in the properties you'll be able to see all of the properties or the parameters that I am either required to mention or I can mention in the instantiate message. So in our case, the best place to look into the requirement would be the type. So so like as you can see, minter is either a string or a null, which means that it is optional. Creator is a string or a null. Name name is a type string, which means that it's important to mention. So this is a required parameter. Symbol is a required parameter. Withdraw address is a string or a null, which is optional. So seems like we only require to mention name and symbol. So I'm just gonna do that. I can also mention minter because this is something that will be important for us in the application that we are building, like in the front end app when we get to it. But for now, let's see. So I'm just going to generate my message, and it's just going to look something like this actually here. So right now I'm just creating a variable message in my bash, and I'm going to give it certain parameters. So first I'm going to put it in quotes. So I'm going to give it a name. Let's just call it test 721. Next would be the symbol. Let's just call it TT. And here, this is our instantiate message that I'm just going to remove these spaces just so it doesn't do anything funny later on. So I'm just going to press enter, and that's my message. So I'm going to use this message to instantiate the contract. And if you remember in Zion-D wasm subcommands, we saw that Zion DTX. It was TX store. Okay, yeah. So in TX store subcommands, we saw that you either have wasm, which is the wasm upload, or we had the instantiate. So actually, I'm just gonna do it. Wasm help. So I should now have instantiate somewhere here. If it's not here, TX wasm. Oh, there it is. So yeah, that's right. So we want to get into Zion DTX wasm, and inside wasm we want to instantiate our wasm contract. So I'm just gonna do instantiate. And for the instantiate, so the first parameter that it takes is the code ID. Actually, I'm just gonna do help just so you can see. So yeah, like I said, so this is exactly what we want to do: create a new instance, and so this is the code ID that it's gonna take. This is the message and other flags that we're gonna look into now. So this is also our last step before we get the contract address. So contact code ID. We already had the code ID stored. For the message, we already had the message stored. And next, we're just going to give it some flags. So the first flag would be from test account. For you, it's going to be different depending on what your key is named in Zion-D. Again, do Zion-D keys list to get to that. Label is usually required for your own for your own labeling. So I can give it something like test NFT and gas prices, gas adjustment, the same sort of things that we did before. So I'm just going to copy that over and paste it here. So here I'm using all of these flags. So again, all of these flags are important for you to sort of paste in here whenever you are doing instantiation or using Zion D. Again, not important to remember all of these flags. I use help command all the time. So you can just use the help command to get to the exact flag that you're requiring or missing. Or you can also just look into our documentation and copy the command over. And that's it. So seems like this went through. I'm just going to quickly check into the Explorer. That was a success, which is great. So now what we require from this transaction is our contract address. And for that, again, we can, because this is not a deployment, it doesn't have those crazy amount of logs that we saw in the previous transaction, we can just look into the JSON here. And that's the amount that it went with. We want to look in so somewhere in the events array is where we get the good stuff. So you want to get into the events. It should be somewhere here. Oops, sorry. Actually, the last attributes array. Oh yeah, there it is. Contract address. So that's the contract address that we'll be interfacing with in our next session, because we don't have a lot of time today to build our front end. But we did deploy our contract on the chain. So we're just going to be using this contract address when we get to building our front end. And that's the contract address. Another way, again, to query this, if you're not using the Explorer or if you don't have access to the Explorer, you can just pick this transaction hash and query it using Zion D query tx this, give it the node, which would be the RPC. Where's my RPC? Here. The node, which is the RPC, and next, I think it should work. Oh yeah, again, it will work. It'll give you all of the logs, but what we do require is the contract address. So again, for that, you can pipe this output JSON into JQ and sort of look for the contract address. Again, that is something that you'll be able to find. This whole command you'll be able to find in the documentation, but I'm just gonna pick this from here and this. So this is where we looked at in the Explorer. Last object in the events array. The key of the object that we're looking for is attributes, and the first object in the attributes, and we're looking for its value. I'm sorry if that didn't make any sense. I'm just going to repeat that. Basically, we want to look into the last object of the events array, and the last object just has two values, attributes and type. We want to look into attributes. We want to look into the first. We want to look in here, the zeroth object of the attributes, which actually should be 0 here. Yeah. So there it is. That's our contract. I'm just going to match it quickly because I was a bit confused here. So 13754x4. Yeah, 13754x4. So that's our contract address. And this is something that we'll be interfacing with. It's always good to check though, like even if you copy this over, this is something that it might change based on the chain upgrades or based on any other upgrades in the way the transaction is being sent or in the way the information is being parsed from the transaction logs. So it's always best to check in the Explorer once. So zeroth, so like here, the zeroth object of the attributes array is the contract address. If I were to add 1 here, it would have given me a different value, and I would have the wrong address for my contract. So it's always best to check in the Explorer and then figure out like what exactly command you want to give here, and then pick your contract address. This is something that we can save in the code file for our next session. So I'm just gonna save it somewhere here. Maybe make a constants.ts. And that's our contract. Oops, sorry. And yeah, that's pretty much it. So I'm just gonna quickly go over like a brief overview of what we went through this entire session, and we're also up on time. So we went over like what exactly a blockchain is. I mentioned it's a distributed data structure. A very high level overview of a blockchain would be a data structure that is maintained by multiple different nodes on multiple different systems, and they all come together with a consensus on agreeing on what the data structure represents. So what the data structure is in the current state and time. Each block is just a collection of transactions. Each transaction is atomic, which means that each transaction can consist of multiple message executions. And if one message is executed, the other isn't, the whole transaction fails, which means that it is atomic. We went over the technical stack of a dApp, or a anatomy of a dApp, which usually includes a client, a chain, an SDK that communicates between the client and the chain, and the backend. Usually there's a backend SDK as well that sort of sits between the client and the chain. But yeah, these are most of the components that you're going to be dealing with, and most of what you're going to be building. The chain, we went into like a brief theoretical explanation of what exactly a chain represents and how you can think and compare different chains. Usually it's nice to have mental models, because I could give you descriptions of Ethereum, Solana, Zion, and why exactly one is better than the other. But if you have mental models that you can go over, or you can use to deploy, you can use to compare your chains, it's always better to have that. So yeah, and that's pretty much it. So you have a state machine, which state machine is basically what a chain is, and you have a function that helps you go from one state to another. And the function basically defines how the state changes, and the state transition function is usually a transaction. Any transaction in a chain is a state transition function. And like the coming to an agreement of this function, or coming to an agreement of what a set of these functions are, is what consensus algorithm is. And yeah, that's it. And then we went over to deploy our first contract on the chain using CWNFTs. And we got to the contract address using the commands that were shared in this video. They're also available in our documentation. You can head over to your first contract, the guide, and you should be able to set up your Cosmosm ID, which is not, you can either use VS Code or the Cosmosm ID, and you can just head over into this whole document. And that's it from me for today.
So thanks a lot for the very detailed workshop. I think it was super cool. I've learned a lot, and I hope also the audience learned a lot. There's some questions from the audience, but we can also let them give some time to digest all the information.
Okay, sure. I can also share the links, like this link from our documentation here. How do I share? Actually, I'm not logged in to reply to the comments on YouTube, but I can share this with you, and maybe you can share it
And we
with.
can drop them here in the comments.
Yeah.
There's like some questions. One is, for instance, like I installed XionD in WSL. Do I have to reinstall all again on WSL?
Oh, is that a Windows machine? Because if it's Windows, I don't think. Oh yeah. Oh, so WSL is what you're probably using to use Zion D in a Linux subsystem on Windows. For that, if Zion D is already in WSL, you don't have to reinstall. Uh, yeah, but yeah, okay, so I get it. So you're asking if you have to reinstall all again on WSL? Yes, you'd have to. So you want to make sure that the Linux subsystem has everything in it for you to do all of the things that we did in this video. So you want to make sure that the Linux subsystem has IOND, Docker, Go, Rust, etc., everything. Because IOND is dependent on Go, so you want to make sure that Go is installed in the same system where IOND is. And you could have Rust separated completely, so you could be building your contracts up outside of the Linux subsystem, as long as Zion D has access to the WASM binary. So you just want to make sure of that.
Okay. We also dropped the link to the docs in the comments.
That's great.
And I think that's it. I think we can like wrap up the session. Anything you want to add?
No, I'm good. Actually, yeah, that is, I spoke a lot. So that was it from me. So I hope it was easy to digest. If not, I am glad the recording is available. I'm also going to share some documentation and some links in the Discord announcements that I've been sharing all this while. But I'm going to be sharing some more. And for tomorrow's session, we would just build on top of what we did today. We'll take the contract address and we'll sort of query it using a front end. And towards the end, I also want to introduce some other frameworks and SDKs that are available for you to do all of this that we did, like in a few seconds. Because we were learning today, so we went into like the deeper details of exactly how contract instantiation works or deployment works. But there are frameworks out there that'll make all of this super simple for everyone. So we're going to be going over that. And I know it was mentioned that it's going to be a 3-part series, but most likely we'll just end up doing 2 parts. And for like if there's anything remaining, I'll maybe share resources so that you guys have enough time to sort of digest and go over it in your own time. Because I'm realizing like during a workshop might be difficult for everyone to follow along, but I'll be sharing links throughout. So most likely it'll be a 2-part series. Tomorrow would be the second part.
Okay. Yeah, looking forward to the session tomorrow. Good teaser for tomorrow. So thanks a lot for this first series and for joining us today. Very excited about tomorrow and also excited about all the projects that are building on top of Xion. And yeah, like feel also free to subscribe to our YouTube and Binance Live to not miss out on the session tomorrow. And see you tomorrow, guys. Thanks a lot for hosting the session.
Thank you. Thank you for the session.